In this video, we'll discuss a little bit more about similar triangles. The first part of this video is going to be pretty straightforward in that it'll just be very intuitive, but there is one kind of counterintuitive result that's not immediately obvious that we'll talk about in this video. So the stuff that's fairly intuitive is if I'm looking at two similar triangles. So let's say I have a triangle and this red triangle is half the size of this blue one in every regard, meaning that the angles pairwise are congruent. So the side lengths are then proportional. It would also make sense that if I was to create, say, a median for this triangle. So let's say I make a median here. Remember, a median cuts an opposite side in half. It would also make sense that these medians would have the same scale factor. This median would be twice the size of the one on the red triangle. So the same idea applies for altitudes and for angle bisectors, in particular where we're looking at the length. Meaning, if we're looking at an angle bisector of a triangle, the length of the angle bisector from here to the opposite side, or from the angle to the opposite side. If I double the size of the triangle, it would also make sense that that length is doubled as well. So those three are fairly intuitive. They're very, very similar to the side lengths. However, there is one result that's a little bit counterintuitive, and it does kind of pertain to the angle bisector. So let's talk about that special case. Let's say I have an angle bisector JM. So we'll say that JM bisects angle KJL. And the idea is, if this happens, and it might seem a little counterintuitive at first, if I am to make a ratio comparing the side lengths of KM, or I guess the cut length there, to LM, well, that ratio would be the same as if I'm to compare JL to JK. This is not something that I typically ask people to prove. This is just a result that's pretty powerful in mathematics. So I'll write it here. We're looking at Km compared to ML is going to be equal to JK as compared to JL. So in other words, if I'm looking at this angle bisector, if I just look at each half of the angle and the opposite sides, well, they will be the same in terms of ratio if I compare them to the sides of the triangle of the angle that I'm bisecting. And it's a little weird in terms of trying to reason it out. It's a little different, but it is a very special result in mathematics, and it can be pretty useful. If we cut an angle in half, then we can determine a lot in terms of side length. We can, if we know the size of the triangle, so for instance, let's say we know that J is 5 and we know that, or JK is 5 and we know that JL is 7, we can determine some of these other lengths. We can make those determinations. So if we knew that KM was 2, we could figure out what ML is if we felt so inclined, and in which case we could also figure out the final side of the triangle. So it's all worth keeping all that in mind. It's more ways to set up proportions to solve for lengths of these triangles.